guys, we're going to be looking at section 10.5 today, where we're going to be applying other angle relationships that are within circles. So as you can see, as I've written here in beautiful calligraphy, we're going to be talking about angle relationships in circles. So what I've got right here is in relation to theorem 10.11, right? So what I've got here is a tangent that's intersecting this circle at point B, right? And I can see that there is a chord AB within the circle, right? So if I want to find the angle measure of angle 1 here, I can utilize the arc measure to find that, right? So it's been stated here that AB, arc AB is equal to 130 degrees. So if I want to find the measure of angle 1, we can look at this and just see angle 1 here is definitely not 130 degrees, right? It's less than 90. And it turns out that if you want to find the measure of angle 1, all you need to do is say measure of angle 1 is equal to 1/2. Wait 1 second, guys. Sorry, I've got to get my pen working. All I've got to do is make this equal to 1/2 of arc AB. So that's going to be equal to half of 130 degrees. Or that's just going to be, what is that, 65 degrees, right? So we can say that the measure of angle 1 is 65 degrees. So let's look over here at this next example and see if we can figure this one out. Okay, so I've been given KL, and I guess we should put a little point over here. Let's make this N, right? So I've got KLN, and I know that the measure of that angle, the measure of angle L, is equal to 125 degrees. Now, in this previous problem, we were given what the arc measure was. Here we're given what the angle measure is, right? And we know that the measure of the angle, right, I can say the measure of angle L is going to be equal to half the measure of arc KJL. And we notice that is a major arc, right? KJL is a major arc because it is greater than 180 degrees. So if I know the measure of angle L, and I need to just adjust the size of this real quick. If I know the measure of angle L, let's replace that with 125 degrees. That's equal to half of the measure of major arc KJL. Well, if I want to solve for the measure of arc KJL, I'm just going to multiply both sides by 2. And that gives me 250 degrees is equal to the measure of arc KJL. All right, so that is theorem 10.11. That is theorem 10.11. Okay, so now let's talk about what can happen when we've got multiple lines crossing through circles, right? When we have two lines cross through a circle, we could have them intersect on the circle, right? These two lines could intersect, and the point at which they meet is on the circle, right there. We could have them intersect inside the circle, and we could have them intersect outside the circle. Now, they're not always going to look just like this, right? And we're going to see that in our next two theorems, right? And our next two theorems are angles inside the circle, right? These angles are created inside these circles, right? And our theorem states that if two chords, right, that's what we have here, if two chords intersect inside a circle, then the measure of each angle, right, I've got measure of angle 1, measure of angle 2, is half the sum of the measures of the arcs intercepted, right? So I'm going to take half the sum, right? I'm adding, I don't know if you can see me circling this right here. We're taking half the sum, that's a plus sign, of its intercepted arc. So measure of angle 1, that's this guy right here, is equal to 1/2 of DC and that was my dog yawning in the background, plus AB. DC plus AB, right? And that's what I've got right here. Measure of angle 1 is going to be equal to 1/2 the measure of DC plus AB. So that means the measure of angle 2 is going to be equal to, and we'll use some different colors here. I'm going to be looking at this arc, AD, and let's see, we haven't used orange, and BC. You see that right there? So we've got measure of angle 2 is going to be equal to 1/2 of, and let's use our colors here, be consistent, the measure of arc BC plus the measure of arc AD. Right? BC and AD here, those are the intercepted arcs in relation to angle 2. So we'll do an example of that in a minute, but let's move on to, well, what if these secants, right? This is a secant here. AC is a secant. What if I have secant AC that passes through the circle, and then I have a tangent B here, right? This tangent intersects at point B, and it creates this angle 1. What am I going to do with that? Well, it turns out what I need to do to find, right, I've got 3 different examples of these guys intersecting outside the circle. To find angle 1, angle 2, or angle 3, what we do is we take half the difference between the big arc that is created, the interior big arc that is created, and the smallest arc, right? So I take the big arc and I put that in purple, and I subtract the smaller arc from that, right? So if I wanted to find the measure of angle 1, and I'm going to have to write a little small here, sorry. The measure of angle 1, that's going to be equal to half big arc, AB, minus small arc, BC. That's for this guy over here. If I wanted to find the measure of angle 2, it's going to be equal to 1/2 the big arc, AB, minus, sorry, we're getting a little small here, minus, oh, well, you know what? Actually, what I need to do here is I need to throw another little point over here so that we have a major arc. I'll throw C there. I'm going to do 1/2 of ACB, right, that major arc, and I'm subtracting, you know what, I might as well just write this on the lower part. Struggling a little bit, but that's all right. I'm going to measure of angle 2 is going to be equal to 1/2 of major arc ACB minus minor arc AB. If I wanted to find the measure of angle 3, that is going to be equal to 1/2 the difference of the bigger arc AB minus the smaller arc DC. All right, I take that big arc that is intercepted from angle 3, and I'm going to subtract that smaller arc from it. So let's look at an example, why don't we? Let's say I've got this going on right here. Right, I've got a tangent and a secant passing through a circle. I know that interior angle is 29 degrees. I know this small intercepted arc, and let's throw color in here. I know this small intercepted arc is X degrees, and I know this big intercepted arc is 114 degrees. We want to solve for X. Well, what we know is that the measure of this angle, 29 degrees, is equal to half the difference of the large arc minus the small arc, right? So I can replace those values with, I can replace the unknowns with the values that I know. And then instead of distributing this 1/2, I'm not going to do this, right? I don't want to do that. What I'm going to do is I'm going to actually multiply both sides by 2. By multiplying this entire thing by 2, right, I cancel out that 1/2, and I now have to multiply 29 times 2. That gives me 58 equaling 114 minus x. And from here, it's just solving for a variable, right? That gives me negative 56 is equal to negative x, right? I subtracted 114 from both sides, giving me x is equal to 56. All right, if you guys have any questions concerning any of the other problems from the homework, don't hesitate to reach out. I'll be available.